Okay, so in this video, I will briefly talk about how the compilation process works. In the previous module, we talked about GCC compiler. So I think it is very important to have some understanding about the compiler itself, because we'll be using a compiler like GCC to build our software, right? So as you can see right here, I have a brief flowchart of how the entire compilation process works, or in other words, what GCC is doing when you issue the compilation command. So everything starts from here, our source code. So the source code is your C source files, the stuff that we'll be writing together in this module. And you can have multiple of these. You can have multiple C files together to build your final software, right? So everything starts right here as a source code. And what a compiler would do first is feed that source code into something called a preprocessor. So in here, it will try to expand the code. But before it does that, it has to check for errors. For example, syntax errors, or if you have missed a semicolon in a line of code, or you mistype some variable, for etc. So you will do the error checking here, and then it will expand. So by expand, I mean to replace your macros with the actual values. And we will talk more about macros later in this course. And in addition, it also remove your comments. So remember, in the software, not every single line is compiled. Okay, you can have your comments for developers to know what the program is doing, and those comments will not be part of the compilation, right? So that's the first step, preprocessor. And then you will feed the expanded code into a compiler module inside GCC. So what it does is it will actually convert the high-level source code into something called the assembly code. So you may have heard the assembly language, which is a lower level programming language that basically describes a series of instructions. Or you can call this a logical units of operations. So this is still somewhat readable by human, and except that it just describe the instructions in more details. Okay, it tells CPU exactly what to do in order to complete certain computation task. Okay, so that's the assembly code. And then in the compiler, it also has an assembler, which converts your assembly code into the actual machine code. Okay, and the machine code is sometimes referred to as object code or object file, and normally it has a .o extension. So for example, myprogram.o. So what it's saying is, if you have a C program, a source file called myprogram.c, and then you feed that into a compiler, it can produce an output of .o. So which means that piece of source file has now converted to an object file in which your CPU understands. Okay, so inside this object file is the actual instruction that tells CPU what to do, or binary file, ones and zeros, stuff like that. And it also contains functions and symbols. So in other words, those are names. So in the object file, we can tell the names of your functions, the names of your global functions, global variables in the program. Okay, so symbols. Okay, sorry about the typo here. And then finally, there's the final module called a linker inside the compiler. And the linker's job is to put together all of your object files. And again, you can have more than one, depending on how many source files you have. So you will combine all of your the object files, including the ones that you compiled right here, and also the ones you introduce to the system. So that could also mean third-party libraries. So your program may be using a routine provided by some other third-party libraries, for example, OpenSSL for encryption and decryption, right? So those object files will also need to be included in the linker process. And mostly for the third-party libraries, it's normally provided as a static library .a or a shared library .so file on Linux. And I think on Windows it's called a DLL file, a dynamically linked library. And on Linux it's called a shared object, so a shared library basically. So you see other object files and library files .a or .so, they will all be fed into a linker process and finally produce your executable. Okay, so basically that's a very brief kind of flow of how the compilation process works. And later in this module we'll be using something called a makefile, and with that makefile we'll be actually configuring and telling the compilers to produce, for example, the object file, and in the end produce the final executable file. And even though it has 2 steps, I mean not 2, sorry, 4 steps right here, but normally I would tend to treat this as a 2-step process, and that's exactly what I would do in the makefile, and I will show you later in the module. And the first process is actually what's on the left, so all these 3, the object files. So normally when I want to compile a program, I will prefer to compile into object files first. Okay, so a compilation can end right here, and the output is a .o file. And remember, .o file is not an executable. And on the second stage, I will take all of my object files and produce the final executable right here. So to me, it's really a 2-step process, but in here I want to show you a little bit more about what happened in between. So that's basically it. And again, I don't think you have to go in too deep of each process, because every single process right here can include a lot of details, which I don't think is necessary for this class. So I think right now it's just to remember this picture right here, remember the object files, the linker, and the executable before moving on to the next modules.